All right, welcome to this explainer. So, fun fact to kick us off right out of the gate, the word algebra actually comes from the Arabic word al-jabr, which literally translates to the reunion of broken parts. And honestly, that is exactly what we're going to be doing today. We're taking the sometimes intimidating, chaotic world of algebra and turning it into a really simple, highly logical toolkit. We're going to reunite those broken parts, build up your confidence, and show you exactly why there are suddenly all these letters mixed in with your numbers. We've got a super clear game plan today, moving from the basic language of variables all the way up to solving actual real-world puzzles. So let's get building. Starting with Section 1, the language of variables. This right here is our foundation. I want you to think of a variable, whether it's an x, a y, an n, an a, whatever, as an empty, flexible box. It's simply a placeholder just waiting for a number to be placed inside it. It doesn't have a fixed value yet, it's just holding space. In everyday life, you might use X for your fluctuating bank balance, or maybe T for the temperature outside. It's an unknown that can change. So instead of writing out long, clunky sentences like, a number adds 7, we just grab our variable box, let's call it n, and write n plus 7. If we wanted to say 5 times a number, we just write 5x. Or a number subtract 3 naturally becomes x minus 3. We are literally just taking spoken words and translating them into a super fast mathematical shorthand. Once we have our letters down, Section 2 is all about keeping things tidy, simplifying expressions. When you have a really long mathematical sentence, you naturally want to tidy it up by collecting what we call like terms. The absolutely crucial rule here is that you can only add terms together if they share the exact same variable. Take the expression x plus 2x plus 3. Step 1. Find the matching items. We've got an x and a 2x. The 3 is just a plain number, so it stays completely separate. Step 2. We collect. 1x plus 2x's gives us 3x's. So our simplified, cleaned-up answer is 3x plus 3. Now, when we have multiple different variables, like 4a plus 2b plus 3a plus b, we group the a's together and the b's together. It's exactly like having apples and bananas. You just don't mix them. 4 apples plus 3 apples is 7 apples. You don't magically get 7 apple bananas, right? In our algebraic shorthand, 4a plus 3a equals 7a, and 2b plus 1b equals 3b. Putting the whole shebang together, our simplified total is 7a plus 3b. And this grouping rule is incredibly consistent. 5x plus 3x is simply 8x. 6y minus 2y leaves us with 4y. Let's try a quick mini challenge. What if we have 2a, 4b, and another single a? Well, you group the a's to get 3a, and you leave the 4b completely alone, giving us a final, totally tidy expression of 3a plus 4b. Moving on to Section 3, solving equations. This is where we actually hunt for that unknown number. I always tell people to think of the equal sign as a perfectly balanced scale. Whatever we do to one side of the equation, we absolutely must do to the other side to keep that scale perfectly balanced. Our ultimate goal is to isolate x. So if we have x plus 5 equals 12, we need to get rid of that plus 5. Step 1, we take 5 away from the left side, which means, you guessed it, we must take 5 away from the right side. 12 minus 5 equals 5. Step 2, we find that x equals 7. Applying that exact same balancing logic, we can quickly decode a few more equations. For y plus 3 equals 10, we just subtract 3 from both sides, telling us y is 7. For n minus 4 equals 6, we do the opposite of subtracting 4, which is adding 4 to both sides, revealing that n equals 10. And listen, this works for any number. Even if it was y minus 10 equals 20, you just add 10 to both sides to get 30. It is always about maintaining that balance. Section 4 introduces substitution. Now this is where the magic happens, and we actually rip open the box to see what's inside. Substitution is the exact moment where algebra turns back into the standard, comfortable arithmetic you already know. Think of it kind of like substituting a player on a sports field. You're just swapping out the letter for a specific number. Once we know the secret value of our variable, the letter leaves the field, the number steps in, and we just solve the math. Let's actually run a play together. Let's replace x with 4 and calculate the final result for the expression 3x plus 5. Step 1, wherever we see an x, we literally just drop in a 4. Since 3x means 3 multiplied by x, this becomes 3 multiplied by 4 plus 5. Step 2 is just standard arithmetic. 3 times 4 is 12. 12 plus 5 equals 17. Let's put this into practice a bit more. If y is 5, then 2y plus 1 becomes 2 times 5, which is 10, plus 1, giving us 11. If a is 3, then 4a minus 2 becomes 4 times 3, minus 2, leaving us with 10. And hey, this even works for negative numbers. If a happens to be negative 1, then 4a minus 2 becomes negative 4 minus 2, which is negative 6. The core rule here never, ever changes. Section 5. Expanding brackets. Now, I know it sounds a little complex, but the rule is actually incredibly straightforward. The absolute golden rule to remember here is that the number on the outside of the brackets acts as a multiplier for absolutely everything trapped inside. Imagine that multiplier on the outside as a delivery driver who has to drop off a package to every single house inside the bracket. In algebraic terms, a multiplied by the group b plus c equals a times b plus a times c. So if we need to expand 3 multiplied by the group x plus 4, we just send our delivery driver out. Step 1. Multiply the outside 3 by the first inside term x, giving us 3x. Step 2. Multiply that exact same outside 3 by the second inside term 4, giving us 12. Write both terms down, and boom, our fully expanded answer is 3x plus 12. Whether there is a plus sign, a minus sign, or numbers already attached to variables inside, that delivery driver still visits every house exactly the same way. 5 times y and 5 times 2 gives us 5y plus 10. 6 times n and 6 times minus 3 gives us 6n minus 18. And 2 times 3a alongside 2 times 4 smoothly expands right out to 6a plus 8. Finally, Section 6, Real-World Word Problems. This is the moment where algebra stops being abstract math on a whiteboard and becomes a massively powerful tool for everyday life. So here is a classic riddle for you. I think of a number. Add 7 to it and get 15. What is my number? Now that might look like a bit of a trick in plain English, but you now have the exact toolkit to instantly decode it. I think of a number. Well, we know exactly what to do with unknowns. We stick them in a box. By systematically translating those words, the mystery just vanishes. Step 1. Let that unknown number be x. Step 2. Write the rest of the sentence as a simple equation. We add 7 to it and get 15. So x plus 7 equals 15. Step 3. We solve it using our perfectly balanced scale. Subtract 7 from both sides, and we quickly find that x equals 8. The puzzle is solved perfectly. You've mastered variables, simplification, equations, substitution, and expanding brackets. You have literally reunited the broken parts. So here's my final thought for you. If algebra is essentially just a structured language for solving mysteries, what complex, everyday puzzles, from figuring out your personal finances to planning your grandest business ideas, are you going to unlock next? Think about that, keep practicing these tools, and I'll see you in the next explainer.